Hey guys, welcome to this Easy Maths video. Today we will be looking at all of the matrices features on the Casio FX-991EX Classwiz calculator. The features that we'll look at will be things like matrix addition, matrix subtraction, matrix multiplication, the determinant of a matrix, the inverse of a matrix, finding the transpose of a matrix, looking at calculations where we take a matrix and raise it to a certain power, and working out how we can input an identity matrix and store it into our calculator. So they're the type of features that we'll be looking at in this video. Okay, so before we can perform any matrix calculations on this calculator, we need to define our matrices first. So to do this, if we select the matrix option, you can do this by going over to the far right hand side where you've got these 4 squares, and then you can press enter, or you can just select the number 4. Now straight away it prompts you to define your matrices first, but if we just press AC to start off with and then press option, we can then get back to this menu by pressing 1 here where we've got define matrix. So that's just to show you how to get back to this menu. So here I've got 2 matrices. I've got this matrix A and this matrix B, and we're going to store them into our calculator. So first we're going to define matrix A. So here we've got mat A, which is option 1. So select 1. And then here it says the number of rows for our matrix. Now in this video we will just be performing calculations on these 2 matrices, which happen to be 2 by 2 matrices. But as you can see on this menu, we could input any matrix from a 1 by 1 matrix to a 4 by 4 matrix. So in that case, if you wanted to enter a 4 by 4 matrix, you would just select 4 here. In this case, we've got a 2 by 2 matrix, so this is going to be 2. And then it says the number of columns for our matrix. Well, again, it's a 2 by 2 matrix, so it's got 2 rows, 2 columns. So we select 2 here. And as you can see, it basically displays a blank matrix filled with zeros. And now we just enter each of the elements of our matrix. So our first element here is 5. So we click 5. Then you just want to press equals, and then it will automatically move to the next cell. So the next cell is in the top right hand corner where we've got the element 3. So we enter 3, select enter, and it automatically moves on to the next cell. So down here in the bottom left hand corner we've got a 1. So we select 1. And then the last element is 2 in this bottom right hand corner. So select 2 and press equals. Okay, so now we've got all of the elements in our matrix. We have fully defined matrix A. So we can press AC, and then we will return back to this screen. So again, we can press option, press 1 for define matrix, and now we want to define matrix B. So matrix B, we just need to select 2. Okay, and again, matrix B is a 2 by 2 matrix, so it's got 2 rows and 2 columns. So we have this blank matrix here. So the first element is -1. So we enter -1, press equals. Then the next element is 7, then 2, and then -3. So now we've entered all of the elements for this matrix. Matrix B has been fully defined. So now we can just press AC and return back to this matrix screen. So now both matrices A and B have been defined, and they are now stored in our calculator. So the next feature we're going to look at is matrix addition. So here we've got the same 2 matrices A and B, and we're going to add these matrices together. So working this out by hand, you just add each of the elements. So here we have 5 plus -1 is 4, 3 plus 7 is 10, 1 plus 2 is 3, and 2 plus -3 is -1. Okay, so to work this out on a calculator, you'll press option to bring up the matrix menu, and now we want to select option 3, which is matrix A. And this is the matrix A which is stored in our calculator. So now we want to add this result to matrix B. So first we press the plus button, and then to bring up matrix B, we press option again, and then press 4 for matrix B. Okay, so now we've got matrix A plus matrix B, and we can just select equals on our calculator. And as you can see here, we end up with this matrix answer value, which is elements of 4, 10, 3, and -1. And that is the exact same matrix that we have here. So that is matrix addition. Also, similarly, we can work out what happens when we take matrix B and subtract it from matrix A. So again, here, when we calculate it by hand, we just subtract each of the elements. So we have 5 minus -1, which is 6. 3 minus 7 is -4. And 1 minus 2 is -1. And 2 minus -3 becomes +5. Okay, so we want to return to our matrix screen, so we press AC. Then to go to the matrix menu, we press Option. And now we want matrix A, so that's 3. This time we're going to subtract, so we're going to press the minus sign and go back to our matrix menu, so press Option. And now we're going to select 4, because we want to subtract matrix B from matrix A. So select 4. So now we've got matrix A minus matrix B. If we press equals, as you can see, we've got 6, -4, -1, and -5. And that is what we worked out here. Next, we're going to look at how we can perform scalar multiplication. So this is where we take some scalar value and multiply it by our matrix. So in this case, we've got the matrix A, which we defined previously, and we're going to multiply this matrix by the number 5. So when calculating this by hand, we just multiply each of the elements by 5. So we get 5 times 5 is 25, 3 times 5 is 15, 1 times 5 is 5, and 2 times 5 is 10. So to work this out on the calculator, if we press AC to go back to the matrix screen, so now we want to do 5 times matrix A. So if we select 5, and then we can press the multiplication key, and now we just need to bring up matrix A. So if we go to the matrix menu by pressing Option, then we can find matrix A by selecting 3. And now we get 5 times matrix A. If we press equals, as you can see, each of our elements, here we've got 25, 15, 5, and 10, which is what we worked out here. Next up, we're going to look at matrix multiplication. So here we've got our two matrices which we defined previously, matrix A and matrix B, and we're going to work out how we get matrix A times matrix B and then matrix B times matrix A. Now, you should know that matrix multiplication is non-commutative, which means that when we change the order of what matrices we're multiplying together, we're going to end up with different answers, and we can see that here. So when calculating matrix multiplication by hand, so say if we're doing matrix A times matrix B and we want to work out this first element, which is in the first row and the first column, then what we would do is we would multiply this element 5 by -1, then we would add 3 times 2. So 5 times -1 is -5, plus 3 times 2 is 6. Of course, -5 plus 6 is 1. And we would do that for each of the elements. So if you wanted to work out this element, 26, which is in the first row, second column, then you take the first row of matrix A and then you take the second column of matrix B and then perform that exact same calculation as we did before. So to work this out on the calculator, if we press AC, and now we can press Option to bring up our matrix menu, press 3 for matrix A, press the multiplication key, and then bring up the matrix menu again and press 4 for matrix B. Now if we select equals, as you can see, we end up with our matrix here, AB, which is 1, 26, 3, and 1. So now we can do the exact same, but working out the matrix BA. So if we press AC, go to Option, first we want to select matrix B, so we press 4, then press the multiplication key, then go back to Option, and now we want matrix A, so that's 3. Press equals, and here you can see we've got the elements 2, 11, 7, and 0, and that is what we worked out here. Next, we're going to work out the determinant of a matrix. So again, we've got our two matrices A and B, and we can work out the determinant of matrix A, which in this case is 7. So calculating this by hand, we would take the product of these two diagonal entries, so 5 times 2, which is 10, and subtract the product of these two diagonal entries, which is 1 times 3, which is 3, and then we subtract those two results, so we get 10 minus 3 is 7. Now, of course, When calculating the determinant of a matrix by hand, the formulas change depending on the size of the matrix. So if we want to work out the determinant of a 3x3 or a 4x4 matrix, we could use a method like minors and cofactors, or we could use Gaussian elimination to reduce our matrix to a lower triangular or upper triangular matrix, and then we could take the product of the diagonal entries. There's lots of different methods to work out the determinants of different matrices. So to do this on the calculator, if we press AC to go back to the matrix screen, then we can select Option to go to the matrix menu. So now we want to scroll down, and as you can see here, option 2 says determinant. So if we select option 2, we end up with det here, which is obviously the determinant function. And now we want to input matrix A into this function. So we press Option and select 3 for matrix A, then we can just close this bracket. If we press equals, we'll see that we get a value of 7, which is what we worked out here. So now we can do the same for matrix B by working out the determinant of matrix B. So if we press AC, press Option, scroll down, go to determinant, so press 2, now press Option again, and we want to select 4 for matrix B, close bracket, and if we select equals, we get -11, which is what we worked out here. Now this last result is taking the determinant of the matrix AB, and that gives us an answer of -77. This happens to be determinant A times determinant B, so we get 7 times -11, which is -77. But to work this out on the calculator, we would have to first take matrix A, multiply it by matrix B, then compute its determinant. So if we do that, if we press AC, then go to Option, we then bring up our matrix menu, scroll down to determinant, press option 2, then go back to the matrix menu, so press Option, select 3 for matrix A, then press the multiplication key, then Option again, and select 4 for matrix B. Then close bracket, and if we press equals, you'll see that we get -77. So that's how we would work it out on the calculator. Next, we're going to see how we can calculate the inverse of these two matrices. So working it out by hand for a 2x2 matrix, we would switch these two diagonal entries. So the 5 would become a 2, and the 2 would become a 5, and then we would take the negative of each of these entries. So 1 becomes -1, and 3 becomes -3. And we multiply this whole matrix by the inverse of the determinant. So it's 1 over the determinant, which in this case is 1 over 7, as we previously worked out that the determinant of A is equal to 7. Okay, so we're going to work out the inverse of A on our calculator. We need to press Option to bring up the matrix menu, and then we need to select option 3, which is matrix A. Now, on this calculator, there is no inverse function, unlike the determinant. However, when writing the inverse of A, we are used to this notation, where we have A raised to the power of -1. And that's how we're going to work it out on our calculator. We're going to raise matrix A to the power of -1, and we can do that by pressing this key here, where we've got X to the power of -1. So as you can see, it's brought up this power, and now we can just select equals. Now, each of our entries are given as decimals. However, if you hover over each entry, so this first entry, you can actually see that in the bottom right hand corner, it displays 2 numbers. And this weird right angle symbol in the middle of these 2 numbers just means that this is a fraction. So this is equivalent to 2 over 7. And we know that this is correct for the first entry, as this is the same as just doing 1/7 times 2, which gives us 2/7. So that's correct. If we look at the next entry, we get -3/7. Well, that is the same as doing 1/7 times -3, so that's correct. And the next option is -1/7, which is the same as doing 1/7 times -1, so that's correct. And the last entry is 5/7, so that's the same as doing 1/7 multiplied by 5. So therefore you can see that's correct, but to get the exact value for each of those entries, you've just got to hover over each entry. So now we can work out the inverse for matrix B. So if we select AC, select option, and now we can select matrix B, so that's option 4. And now we can do the exact same, so we just press this button here, x to the power -1, select equals, and if we compare this against our answer here, our first entry is 3/11. Well, that is the same as doing -1/11 times -3, which gives us 3/11, so that's correct. Next entry is 7/11, so that's -1/11 times -7, which gives us 7/11, so that's correct. This entry here is 2/11, so that's the same as doing -1/11 times -2, which gives us 2/11, so that's correct. And the last entry is 1/11, which is the same as doing -1/11 times -1. So that is correct. Now the next thing we're going to work out is the inverse of matrix AB. So that's multiplying these two matrices together and then working out its inverse. Now, and if we were doing this by hand, we would have to first take the inverse of matrix B and then multiply it by the inverse of matrix A. So when using our calculator, we can work out the inverse of AB by either taking the left-hand side of this identity or the right-hand side of this identity. If we press AC, and I'm going to enter the left-hand side of this identity, so I can put an open bracket here. I want to then bring up matrix A, so I'm going to press Option, then select 3 for matrix A, then press the multiplication key, then go back to the matrix menu and select option 4 for matrix B. Now I can close this bracket and I can raise all of this to the power of -1. So I press this key here, select equals. Now as you can see from my first entry I get -1/77, which is this number times 1. So that's correct. Our next entry is 26/77, which is the same as doing -1/77 times -26. So that's correct. This entry gives us 3/77, so that's the same as doing -1/77 times -3, which gives us 3/77. And the last entry here is -1/77, which is the same as doing -1/77 times 1. So as you can see, that's correct. We're going to look at the transpose of a matrix. So in order to work this out by hand, if we look at matrix A, to work out its transpose, all of the rows are going to become columns. So this first row here, where we've got 5, 3, is now going to become this column down here. And same with this row, where we've got the entries 1, 2, it will then become this column down here. So they're fairly easy to work out by hand, but I'll show you how to work it out on the calculator. So if we press AC, press Option, and then if we scroll down, you'll see we've got this option 3, which says transposition. So select 3, you end up with this transposition function. Select Option again, and now we want to bring up matrix A, which is option 3. Close bracket, select equals, and as you can see, first entry is a 5, which we've got here. Second entry is a 1, which we've got here. Next entry after that is a 3, got 3 here. The last entry is a 2, and we've got a 2 here. So now we can do the same for matrix B. So if we press AC, go to Option, scroll down, select Transposition, option 3, go back to Option, select option 4, which is matrix B, close bracket, select equals. First entry is -1, which we've got here. Then we've got 2, which is this entry here. 7, which is this entry here. And the last entry is -3, which we've got here. So that is how you work out the transpositions. Next, we're going to look at the powers of matrices. So if we take a matrix and we raise it to some power, we can work that out on the calculator. Now, as a heads up, the calculator doesn't let you enter powers which are greater than 3. So you can only work out basically matrices raised to the second power or the third power. So we'll have a look at that first. I will show you a method of working out higher powers of matrices using this calculator on the next slide. So first we've got this matrix A, and we want to compute A squared. So if we were working this out by hand, I would just perform matrix multiplication on matrix A with itself, and we would end up with this result here. So if we press AC, then select Option, and then we want to scroll down to option 3, which is matrix A, and now we want to square this result. So if we select this button here, which says x squared, we can then raise this to the power of 2, press equals, and as you can see for this first entry I get 28, which is what I got here. Next entry is 21, which is what I got here. We've got a 7 here, and the last entry is also a 7, so that works. What if we want to raise a matrix to the third power? Well, we can do that here. Here we've got the matrix B, and here I've got B cubed. So if I was going to work this out by hand, first I would work out B squared, and then I would multiply the matrix for B squared by the matrix B, and then I would end up with this result here. So if we select AC, go to Option, select option 4, which is matrix B. Now to raise this to the third power, what you should see here above the x squared key is we've got this yellow x cubed symbol here. So that means if we select Shift and then press x squared, this matrix will then be raised to the third power. Press equals, and we end up with minus 71 for the first entry, which is correct, 189, which is what I've got there, 54, and minus 125 for the last entry. So that is correct. So now we're going to look at higher power of matrices. So as I said previously, this calculator cannot compute powers of matrices above 3. So here we've got the matrix A, and if we wanted to work out matrix A to the power of 5, then we would have to split this up into 2 matrices. And each of those matrices would either have to be in powers of 1, 2, or 3. So in this case, matrix A to the power of 5 is equivalent to matrix A to the power of 3 times matrix A to the power of 2. And this is just from the law of indices. The law of indices applies to matrices, so that when we multiply these 2 matrices together, we can just add the powers. 3 plus 2 gives us 5. So this is exactly what we're going to enter into our calculator. So if we press AC, then select option, then we want to select option 3 for matrix A. And first we want to raise this to the power of 3. So to do that we press Shift, then press x squared, and we get matrix A all raised to the power of 3. And then if we press the multiplication key, we can then multiply this by matrix A raised to the power of 2. So if we press option, then select option 3 again for matrix A, then we can press the x squared key to raise this to the power of 2. Press equals, and as you can see, we end up with our first entry of 5,390, which is correct, 4,263, which is also correct, 1,421, and lastly 1,127, which is what we've got here. It's not the most ideal way in working out higher powers of matrices. I mean, it would be better if, say, if we could go back to AC, press option, select matrix A, which is 3, and then press this key here, and then raise it to the power of 5, you'll see that when I press equals, it gives me a syntax error. What we're going to look at is storing identity matrices into this calculator. Here we're going to store the 2x2 identity matrix. So what we want to do is we want to press the option key, and then if we scroll down to the second page, you'll see option 4 says identity. So if we select option 4, we then end up with this identity function. And all we have to do here is enter the size of this matrix. So because we're looking at the 2x2 identity matrix, we input a value of 2 here. Close bracket, and now if we press equals, you'll see that I end up with the 2x2 identity matrix. Now this value has been stored as matrix answer. So if I want to then use this value again, say I want to take matrix A and multiply it by the identity, well, I know that's going to give me matrix A, but if we just test that, then we can press AC, go to option, select matrix A, which is option 3, press the multiplication key. Now if we press option, and if we scroll down to this second page, you'll see that the first option is matrix answer. So if you select option 1, it will bring you up with matrix A times matrix answer, and we should get matrix A. And as you can see, we've got the entries here 5, 3, 1, and 2, and these were the same entries for matrix A.